Hey, what do you say there, math leaguers? It's Mr. T here. This is the second of like 3 little videos that I'm making to kind of wrap up and go over the problems from week 1. And again, if you saw my other little video, I'm going to apologize, especially for you new ones. Week 1 was kind of a mess. There were a couple of mistakes, and one of the problems was just too hard. But here's problems 1 through 10, but not counting problem number 2, which I made a separate video for, and you can go and watch that if you want. But again, really crazy hard, no need to. There's not going to be any others like that. And like I said, 1 through 10, also not counting number 4 because there was a mistake on that one. And there was even a small mistake on number 6 as well. But I'll talk about that one. Okay, so problem number 1 from last week. Even that was quite hard, probably a little too hard for a problem number 1, but it said what 2 numbers are such, like integers, are such that the difference of their squares is equal to twice the square of their difference. And then it asks you to write those 2 numbers as a ratio of the smaller to the larger. An old problem I found somewhere. All right. Anyway, the difference of their squares. I went through this one in the midweek hints. I'm not going to spend too much time. We're going to go a little guess and check. But if you started saying like the 2 numbers, there was a distance of 1 between them, like 3 and 2 or 4 and 3, 5 and 4, you would notice it never worked out. And you would notice if you started getting a bigger distance, you know, like say like 3, like 5 and 2 or 6 and 3, or even a big distance like 10, like 11 and 1 or 12 and 2, you would notice that you're going to get too far away from this statement being true. So a gap of 2, and then we had to just try like small numbers. So they ended up being 3 and 1. It was really kind of a find patterns and guess and check kind of experience. But the difference of their squares, 3 squared is 9, 1 squared is 1, the difference of their squares is 8, is equal to twice the square of their difference. Well, their difference is 2, the square of their difference is 4, twice 4 is 8. So that was number 1. Number 2, like I said, it's on a separate video, it's crazy hard. Number 3 was a nice sort of normal, easy problem, okay? It says that there's like a classroom and there's 27 boys and 45% of the classroom is boys, okay? So 45%, that's a way of writing 45%, 0.45 of, I gave X as a variable, like X is like the amount of kids in the classroom, is 27. 45% of the kids in the class is 27, okay? Now, when I'm solving this problem, I could divide both sides by 0.45, okay? I like to use fractions for stuff like this. That's 9/20 x equals 27. When I do like solving for a variable, I like to say like once upon a time there was an x. We want to get him alone. Right now he's multiplied by 9/20. So how do we undo that? We divide by 9/20. But if you remember, dividing by a fraction is the same as multiplying by its reciprocal, 29ths. And look, you die, you die, you die, you die, x is all alone now. But if I multiply that side by 29ths, I have to multiply that side by 29ths. I like to put a little 1 under there. I'm going to kill a 9 there. So I'm going to get 3 times 20, x equals 60. So there were 60 kids in the class, okay? Number 4, there was a mistake on. I apologize. It was asking for a Pythagorean triple with certain specifications. It didn't exist. I had it in my head, but I wrote it differently on the computer. Number 5 was about triangular numbers. Now guys, if you're doing math contests, math counts, AMC, the contests that I'm doing right now, the math league, And I'm going to keep trying to expand the math league, especially if you're local in Cincinnati. We're going to try to have some more tournaments and things like that. But we love patterns, Fibonacci numbers, triangular numbers, rectangular numbers, things like that, okay? Stuff from the Pascal's triangle. It's all really cool. But anyway, it's pretty simple. There's a formula for triangular numbers. So the nth triangular number, like the fifth triangular number, would be like n is 5. The nth triangular number has a formula, n times n plus 1 divided by 2. So the 12th triangular number is what it asks for. It's 12 times 12 plus 1, so 12 times 13 divided by 2. Now again, I like to write it out and kill my fraction, and so 6 times 13 is 78. Now number 6, okay, again, there was like a little, like, not even an error, but like a discrepancy. There's a thing called, just as there's triangular numbers, there's a thing called rectangular numbers, okay, also known as pronic numbers. And if you look it up, some people say that 0 is the first rectangular or pronic number. Some people say that 2 is the first rectangular or pronic number. So I gave you a formula that has 2 as the first one, but then I said 0 was the first one, so that's where it got a little bit messy. But these are easy. It's plugging numbers into a formula. The formula for rectangular numbers, especially if you don't have 0 be the first one, okay, but it's like 0, like, what is 0? 0 times 1, 2 is 1 times 2, 6 is 2 times 3, okay? So it's like the number times the number after it. So it's n times n plus 1, okay? So it's asking for the 10th triangular number, which is 10 times 11, and that's it, right? And you don't divide by 2, right? Just like with where you're finding the area of a rectangle, you just do base times height, not base times height divided by 2. Did you know that the rectangular numbers are double the triangular numbers? The triangular numbers are 1, 3, 6, right? The rectangular numbers are 2, 6, 12. It's kind of cool. All right. Anyway, so the answer should have been 110. But if you go by 0 being the first one, then it would the 10th rectangular number would actually be where n is like 9. So it'd be like 9 times 10 is 90. That's what I had in the answer box. Some of you probably tried to put in 110, and from now on we can just go with the formula, okay? Now, that was number 6. The rest of these are good. Number 7. It was asking, it's a pentagon, all right, and it said, let me see what the problem says. Number 7, it says it's pentagonal numbers. Pentagonal numbers. Again, just a formula. Okay? Formula for pentagonal numbers is n times the quantity 3n minus 1 all over 2. Okay? So it was asking for the 8th pentagonal number. So 8 times 3 times 8 is 24 minus 1. So, and then all over 2. So we cancel the 8 and the 2. We get 4 times 23, which is 92. Okay. Question number 8. So those, like the triangular, the rectangular, and pentagonal numbers, actually kind of easy problems. It was just plugging numbers into the formula. If I didn't mess up number 6. There's one on this week. There is such a thing as hexagonal numbers, okay? And there's a formula for that. All right, next one says this, it gave this 10 factorial over 7 factorial times 3 factorial is equal to n factorial. So what's the value of n? Or maybe it was an x, I forget what it was, okay? But anyway, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we do 10 factorial over 7 factorial, then everything from 7 factorial down gets canceled. So we're left with 10 times 9 times 8. Now we got to divide by 3 times 2 times 1, and we could cancel this, right? 9 and 3, we could get 3 and 1. 8 and 2, we could get 4 and 1. So we get 10 times 3 is 30 times 4 is 120. 120 is that a factorial? Yes. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So 5 factorial is 120. So the answer was 5. What factorial? What is n? Okay. The next one, I love these. These are like just one of my favorite kind of trick problems. There's always like a guy named Bob who always wants to have a 90 average on his test. Usually I'll give you the first few scores and say, what does he need on his last test? Okay, this time I just mixed it up a little bit and said he's going to have a big exam that counts for 2 tests. Anyway, if his big exam counts for 2 tests, there's going to be 5 tests, okay? Now, you could say, if he wants to have a 90 average, he's going to need 450 total points. 5 times 90 is 450. But here's how I like to do it. First 3 tests. 77. He's down 13 points from his 90 goal. 92. That's up 2 points from his 90 goal. 95. That's up 5 points from his 90 goal. Okay? And so minus 13 and plus 7. He's down 6 points. He needs to make up those 6 points on his final exam. Now remember, his final exam counts twice. So there's going to be 2 tests. It's like there's 2 extra slots where he's got to make up 6 points above 90. So it'd be 93 and 93, right? Even though it's 1 test, it counts as 2. So it's like he's getting 2 93s. Okay? All right, number 10 was actually pretty easy. Number 10 said you got a point -2, 3. So that's x-axis, y-axis, -2 over 3 high. And it says it runs over to another point that's in the first quadrant. So you need to make sure that you're over here. And it had something, I forget what letter it was, A or X or whatever. Okay? And something 3. So look, if their height of both of them is 3, it's just a straight line. And it says the straight line is 6 units. So if we're going from -2 and we're going 6 units over, we're going to get out to 4. Okay? So the answer was 4. All right. That's the video number 2, the 1 through 10 minus the ones that were no good. All right. And stay tuned for the next video.